see how this works. What's that? Yeah, we're technically live right now. So if you pull out your phone and you go to YouTube, you should be able to see that I am live streaming at this moment. And like I said, moving forward, if someone in the class could help me by monitoring comments a little bit, that would be super appreciated. All right. Today we're not really going to be learning anything new. Who here did those practice questions, the pages on speed and velocity? 2 people? Okay. So we're going to do a couple example problems then. And we're going to keep it very similar to my last class. So let's say first example. Let's say Benjamin here, is getting his driver's license, but he's sick and tired of waiting. So he decides, I'm not walking to school, it sucks out, I'm going to drive my parents' car. So you drive to school. Let's say we'll say 30 kilometers an hour. And it takes 20 minutes. How far do you live? How far do you live? Now, there's a key point here in physics, very key point. If I were to plug this into our speed formula right now, actually, let's do that. Let's do that. What's my formula for speed, by the way? Yeah. Yeah, my speed is going to be, my average speed that is going to be my total distance over my total time. Right, it's going to be my total distance over my total time. What is my distance I covered? Do we know that? What are we looking for? We're looking for distance. How far away do you live, right? We're looking for distance. So how do I isolate my distance here?
The average speed times time.
Yeah. How did you do that? Well, we're going to multiply both sides by time, right? We're just doing solving for x. And my time here is going to cancel out. Why does our time cancel out? Why do we say mathematically this cancels out? Because that's just how it works. Well, let's think about this a little differently. What is 1 divided by 1? 1. What's 2 divided by 2? What's 3 divided by 3? Right? You get the idea. So t divided by t, these both represent some number, but it's the same number. So t divided by t is 1, aka we can cancel it out, because anything times 1 is just itself. So that's why this cancellation method works. That's why when you're solving for x, right, you do the opposite operation. It cancels it out. All right, so we have now d is equal to our average velocity, or I keep using the word velocity, our average speed here times our time. Now, what is my speed, my average speed? What did I tell you it is? 30 kilometers per hour. What was my time? 20 minutes. So what's my answer here? What's 3 times 2? 6, add a couple zeros. 600. Do you think that's the right answer, though?
No.
Clearly, because I wouldn't be asking that question otherwise. Why is that the wrong answer? Sure, let's put some units there. I'm just going to say that this is kilometers. Is that right now? No. Think about this logically for a moment. If you were driving to school and it took you 20 minutes to get to school, is it possible that you live 600 kilometers away? No, that's insane. That's crazy town, right? So you always got to ask yourself, does it make sense? If I write that on your piece of paper, that means your answer is wackadoodles, right? Your answer makes no sense at all. So, why did we get this answer, though? Why did we get this answer? What did I not include here? Yep.
The 20's in minutes and not in hours.
Nailed it. So the 20 is in minutes, not in hours. When we include our units, it's much more clear to see that our answer makes no sense at all. Right? So 30 kilometers per hour, if I multiply this by 20 minutes, well, what's my units here? It's not kilometers like I wrote. This would be 600 kilometers times minutes over hours. Is that how you talk to people? If I said, how far was your walk to school today? Would you say, yeah, it's just 600 kilometers per minute per hour, or 600 kilometers times minutes per hour? No, that's insane, right? No one would say that. So how can we make this answer make sense? Yeah?
Instead of 20 minutes, you could put 1/3 of an hour.
Excellent. Excellent. So when we are doing problems like this, it's very important. So in physics, your units must match. Right? Your units must match. Especially when we're talking about speed and velocity. Not as much when we're talking about acceleration, we'll get there. But for speed velocity, if we're going to be doing problems like this, your units got to match. Otherwise, your answers are going to be wackadoodles. So, how are we going to convert minutes to hours? Well, someone tell me, you guys all know this, how many minutes are there in an hour? There's 60. So, in 1 hour, there are 60 minutes. Now in math and in physics, you'll be working with this a lot. These are called conversion factors. Okay, this is your conversion factor. Now if I want to convert from minutes to hours or hours to minutes, I will be utilizing this. So we have 20 minutes, and let's convert that to hours. Well, am I going to multiply this by 1 over 60 or 60 over 1? What do you think?
1/60.
Why 1 over 60? Well, if we write in our units, it makes a lot of sense, because in 1 hour, there are 60 minutes. So if we look, well, what's minutes divided by minutes? It's going to be 1. It's going to cancel out, right? We're going to cancel out our minutes. Now, again, students often get confused by this. They're like, well, what do you mean? This is different than this. Right? This is different than this. But what's the rule when you're multiplying fractions? Let's say you had 1/4 times 2/3. What would be the answer to that? Yep. 1/6. But let's keep it simple. Before you reduce that, what would it be?
2/12.
2/12. So what did you do?
Reduce.
No. What did you do to get 2/12?
Oh, simplify the 2 and 4.
That's not how you got 2/12.
Oh, you multiplied 1 times 2. But
There you go. So you multiplied your numerators and you multiplied your denominators, right? So we're doing the same thing here. This is like 20 over 1. And we multiply our numerators. Let's not cancel out minutes right now. Let's actually do the math and let's figure out what our units are. So what's 20 times 1? Well, that's 20. Minutes times hours. And then we have 1 times 60 minutes. What's that? So 60 minutes. And you can see here, what's minutes divided by minutes? It's going to cancel out. Right? That's going to cancel out. And that's going to leave us with hours. So what is 20 divided by 60? 1/3, 0.333. Right? That's a third of an hour. Does everyone follow? Does that make sense? Right? We always want to cancel out our units and be left with the ones we want. Right? That's how we're going to utilize conversion factors in this course. So now let's see if our answer is going to make sense. So we're going to plug in 30 kilometers per hour. And we're now going to plug in, well, how long did we travel? Well, a third of an hour. So how far away are you from home? Nope. 10. Right? So 30 divided by 3 is 10, right? Our hours are going to cancel out, so we have 10 kilometers is the answer. So I know I did some theoretical math stuff there, but we're going to be working with a lot of conversions. This will eventually become second nature. You know what, let's do a really challenging conversion problem. I feel like doing that right now. Let's screw around with conversions a bit more. So let's say you were traveling 25 meters per second. So me and Ippy were in a race together, and Ippy was running 25 meters per second. Is that fast, or is that slow? Yeah? Yeah, on foot, that's pretty quick. But the thing is, we don't have a good conception of meters per second, despite the fact that this is how we effectively measure velocity and speed in physics. We almost always use meters per second. We have a very intuitive sense for kilometers per hour. So let's see how fast this is. We're going to see how fast this is. So let's convert this to kilometers per hour. That is our goal here. We're eventually going to convert this into kilometers per hour. So how am I going to do that? How am I going to convert that to kilometers per hour? Well, the easiest way to do this is to tackle the problem one step at a time, one conversion at a time. And I'm always going to be giving you units that you use in your everyday life. I'm not going to be asking you for picoseconds or decimeters or megameters or weird units that you don't understand. It's always going to be kilometers, centimeters, millimeters, meters. It's always going to be seconds, minutes, hours, days, years, months. Right? I'm never going to give you anything that you are unfamiliar with. Actually, it won't be months because months have variable numbers of days. All right, so how will I convert this? Well, let's convert to kilometers first. Right? What is my conversion factor for kilometers? Well, in 1 kilometer, there is 1,000 meters. So what am I going to multiply this by? What am I going to multiply that by? Nope, my options are 1 over 1,000 or 1,000 over 1. Think about the units. I want to cancel out meters and I want to be left with kilometers, yeah?
1 over 1,000.
Yeah, 1 over 1,000, because in 1 kilometer there are 1,000 meters. Here, meters is going to cancel out. Let's find a red marker that's not dead here. Meters are going to cancel out, and we are going to be left with kilometers. Is that our goal? Do we want kilometers? Yeah, it is, right? So we have converted our distance now. If I were to multiply this together, I would get my answer in kilometers per second, but we don't want that. We want kilometers per hour. So how do I change that to hours? Well, let's think about this. How many seconds are in a minute? There's 60 seconds. How many minutes are in an hour? Right? So Am I going to multiply by 60 over 1 or 1 over 60? Not 1 over 60. It'll be 60 over 1. Now, if you're ever asking yourself that question, remember, your units need to cancel out. So if we have seconds on the bottom, we need seconds on the top here. So my seconds cancel out, and now I'm given kilometers per minute. Is that our desired units?
Yes.
It is not. We don't want kilometers per minute. What do we want? Per hour. So now I have to cancel out my minutes. And I'm going to do that by multiplying by 60 minutes in 1 hour. Right? Our minutes here cancel out. And are we left with hours now? We are. Right? We are. Now, this looks super crazy and complicated, but in essence, what did I do here? Think about that. What did I do? What's 60 times 60? 60 times 60 is not 1,200. 3,600, good job. And what did I do for my denominator? What did I divide this number by? Well, I divided it by 1,000, right? I'm just multiplying out here. Well, we did 1 times 60 times 60, that's 3,600. We did 1,000 times 1 times 1, that's 1,000. What's 3,600 divided by 1,000? Not a trick question. Yeah? Yes, 3.6. So, there's a little cheat here. If you really cannot remember how to convert from meters per second to kilometers an hour, you can just use 3.6. Right? You can multiply by 3.6. The answer, if you do this in your calculators, 25 divided by 1,000 times 60 times 60, you should get 90 kilometers per hour. So was Ippy running pretty quick? Yeah, you are the fastest human to have ever lived by a large margin. Nothing comes even close. So you're moving crazy fast. Now, how would I go from kilometers an hour to meters per second? Well, I have to multiply by 3.6 to get here. What do I have to do to get to meters per second? Divide by 3.6. Right? So you can always cheat a little bit when it comes to that, because this will never change when we are converting from kilometers an hour to meters per second, or meters per second to kilometers an hour. Now, this probably looks really confusing to a lot of you, but this is an essential skill for both physics and chemistry at a grade 11 level. Working with units and learning how to do that now is going to help you out a ton next year. All right, so let's now explore another practice question here. Let's say, for example, you know what, let's make this a little easier for your practice problems in your booklets. Let's say Miriam was running to school, and you know what, she's a good runner. I wanted to see if she's going to make the national track team. So I was recording and seeing how long did it take her, so not how long did it take her, how far did she travel with each 1 minute interval. So I then plotted that on a graph. I said, okay, let's say that this is the distance you covered, and this is my time in minutes here. And we say, actually, this is going to be distance in meters. And let's say after 1 minute, you traveled 1 meter in a minute? That's like slower than a tortoise. What would be a good number that you could travel in 1 minute? Someone give me some reasonable number. 32. 32, still super slow. But we'll say in 1 minute you were, yep. Sure, 100 meters. We're going to say from 1 minute to 2. This is actually, oh, I'm reversing the numbers here. My bad. This is going to be 100 meters. Now, from 1 to 2 minutes, This is actually going to be here, I changed my mind. This is going to be your change in position, not your distance. Your change in position. Okay, it's going to be a change in your position. So from 2 minutes, we're going to say she traveled 220. From 2 to 3, we're going to say 380. And from 3 to 4, let's say 470. Why not? So that's how she ran over the course of 4 minutes. Now, I want to know, based on this information, what was my average velocity for this journey, and I also want to know what was the max velocity that she achieved during this 4-minute interval. Okay, so take a minute right now, try to figure that out. So what was the maximum velocity achieved, and what was the average velocity? Remember, this here is your change in position, right? From your starting point, how far out of position are you? Any questions for Michael? So for these here, you can't circle them. You have to put them on a line. Okay, so if you want to just, you don't need to really erase it, I don't think, but if you want to just add like a line in the boxes, that'd be great. Put your name on it. So pretty, right? You get different colors in here. No paper on you today?
I'm just lazy.
Yeah, fair enough. Looks like the majority of you here don't know where to start. That's okay. Alright, so what was my average velocity? For the entire journey, what was my average velocity? How would I figure that out? Yeah?
So it would be like 470 meters divided by 4, which would give you 117.5.
Perfect. Yeah. So when I'm talking about an average velocity, over our entire journey, does velocity care about the path we take, really? Not really, no, right? But also for speed, if I was asking you for your average speed, you would use this same process. Your average speed is your total distance over total time. My average velocity here for this entire journey is going to be my total displacement over my total time. So what was my total change in position, my displacement, and what was my change in time? So what was my total change in position, my displacement? Yeah. By the way, if I don't give you direction, you're just going to be using positive, negative. So you don't really need to list a direction because I didn't give you one. What was my total change in time? 4 minutes. Which means that, what was my average velocity? Yep. 117.5. What are my units?
Meters per minute.
Meters per minute. So that was my average velocity, but in my opinion, the more important question, because it's getting you to think about velocity a little bit, is what was my max velocity? So I want you to think about this question for a second. Let's say I am driving to school, okay? Now, I track how far I travel every minute. Which minute will I be traveling the fastest? How could I tell which minute I'm traveling the fastest?
How far you go?
Oh, excellent, Josh. How far you go. Clearly that makes sense, right? If I'm traveling 100 kilometers an hour versus, say, 10 kilometers an hour, and I travel for 1 minute, over which minute am I going to travel further? 100 kilometers an hour or 10 kilometers an hour? 100, right? I'm going way faster. So if I'm going way faster, I'm going to cover much more distance in the same amount of time. So it stands to reason that the 1 minute interval here that I covered the most distance is going to be the minute interval in which I was traveling the fastest. So which of these intervals did I cover the most distance? Did I have the greatest change in position?
380.
Which one?
380.
Excellent. Right, from minute 2 to 3. If we look here from minute 0 to 1, what was my displacement?
100.
Yeah. What was my displacement from 100 to 120?
120.
That was 120. What was my displacement from 220 to 380?
160.
160. And then lastly, what was my displacement from 380 to 470?
90.
90. So you can see that the minute I covered the greatest distance was from minute 2 to 3. How fast was I going? Well, my velocity over that minute, we can, let's actually break down the formula. What is our change in position equal to? If you look at that formula that we wrote in your notes, what is it equal to? My battery's almost dead here. What is that equal to? Remember, it's equal to your final minus initial. And we're going to have our final minus initial time here. So we started at 220. We went to 380. So that's going to be 380 minus 220. And again, you don't really need to write this out because we did the math intuitively in our heads, but I'm just going to show it to you. And then we were at 3 minutes, and we started at 2 minutes. So we get an answer of 160 meters per minute. That was our max velocity, the 1 minute interval over which we covered the greatest distance. Does that make sense? Okay. So you have a practice question just like this in your booklets, but you have another one where it asks you to do the same type of mental gymnastics, except the variables are switched. Now you will have constant distance intervals over which you are going to measure how long it takes. So really try to put meaning to these numbers. In my last class, I had a lot of students who were literally calculating for every single minute what their speed would be, and they weren't thinking about, well, what would represent my greatest velocity? Well, that would be the most distance covered in that minute. Any questions at all? No questions? Okay, so you have the rest of the class to work on those practice questions. Call me over if at any point you are not sure what to do. Oh, by the way, was there any online questions? Was anybody monitoring? You don't think so? Yeah, it looks like no one typed anything in chat. 4 people are watching it. That's fine.